so let's go over these 3 questions. If you got it right and understand it, feel free to fast forward or just listen to me anyway. All right, the graph of a function f is shown above. If the limit as x approaches b exists and f is not continuous at b, then b equals. So we need the limit to exist, but the function to not be continuous. Let's start with the choices. -1. Well, the limit does not exist. 0. The limit exists, but the function is not continuous. So that is our answer. It's not continuous because the limit is 2, but the value of the function is like 1.5. All right. The other ones, let's see. 1 is continuous. 2, the limit does not exist. And 3 is continuous. All right, 2. For what values of x is f not continuous? All right, well, looks like the function is defined everywhere. So now we just need to see if the limit exists and if the limit equals the value of the function. Let's start with 0. So the limit as x approaches 0 from the left would be less than 0. So that's sine x, so sine of 0, which is 0. And the limit as x approaches 0 from the right would be between 0 and 1, so that's 0 squared, which is 0. So the limit is 0, and f of 0 is also x squared, so that's also 0. So the function is continuous at 0, limit exists equals the function value. So not continuous, we cancel out 0 or anything that has 0 in the answer choice. So now we're down to 1 and 2. Let's try 1. So from the left, the limit as x approaches 1 from the left would be between 0 and 1, so that's 1 squared, which is 1. And from the right, as x approaches 1, would be here, 2 minus 1, which is 1. Oops, 2 minus 1, which is 1. So the limit exists, it's 1, and f of 1 is here, where it equals is also 1. Okay, so limit exists and it equals a function value, so it is continuous at 1. That must be 2 is the answer. Let's just quickly check. 2 minus 2, that's from the left, is 0, but 2 minus 3 is -1. So the limit doesn't exist because the limit from the left doesn't equal the limit from the right. Okay. All right, last one. The graph of f is shown above. Which of the following statements is true? F is discontinuous at 0 because the limit as x approaches 0 does not exist. All right, so 0, the limit does exist, it's 1. Even though there's a hole there, the limit still exists. Okay, f is discontinuous at 3 because the limit does not equal the function value. Yes, that's true. Let's just double check the others. It's discontinuous at 5 because the limit from the left does not exist. So the limit from the left is 4, it exists. The limit altogether doesn't exist, but from 5 does exist. And discontinuous at 6 because, it's continuous at 6, so definitely not that. All right, do the quick exit ticket just to see your mastery if you're still confused by anything, and then the assignment on Delta Math. All right, see you live again tomorrow, Wednesday.